Hi everyone. In this video, I'm going to go through section 4.2 of your lab handout, which is building the envelope detector circuit as part of the Superheterodyne receiver. Our envelope detector will consist of a 1N914 p-n junction diode, a 47 kiloohm resistor, and a 4.7 nanofarad capacitor. So first, I'm going to place the p-n junction diode into my circuit. Note that the black end of the p-n junction diode corresponds to the negative terminal. Next, I'm going to connect my 47 kiloohm resistor. Now, a 47 kiloohm resistor has a color combination of yellow, purple, orange. So take out a yellow, purple, orange resistor from your kit, connect one end to the p-n junction diode, and then the other end to ground. Now I'm going to connect the 4.7 nanofarad capacitor in parallel with the resistor. And we have finished building our envelope detector circuit. Now let's add the channel 1 and channel 2 measurements. Channel 1 will be the input voltage, and channel 2 will correspond to the output voltage, which is the voltage across the IC parallel configuration. And then our waveform generator input will go directly to the positive terminal of the p-n junction diode. Now we can head over to the Waveforms app and then test the operation of our envelope detector by using the waveform generator and the oscilloscope to apply an AM modulated input and then view the output of our envelope detector. Double-click on the Waveforms app. In the waveform generator, instead of using a simple type, we're going to use the modulation type. Our carrier is going to be a sine function. The carrier frequency is going to be set to 200 kilohertz. Since we're not looking at frequency modulation, deselect the FM checkbox. Our envelope is going to have a frequency of 1 kilohertz for part B. Our modulation depth is 50%, and the carrier amplitude A is 2 volts. Now we can press run, and then head over to our oscilloscope to view the output. Oh, I just realized that I set the frequency of our envelope to 1 hertz. This should be 1 kilohertz. And as you can see, except for a DC offset, our envelope detector is very accurately detecting the envelope of our AM modulated signal. For part C, we're going to use a triangle wave for our envelope. So change the type of the envelope from sine to triangle. This is the output of our envelope detector when the input is an AM modulated triangle wave. And then for the last part, we're going to go back to a sine envelope function, but instead of using a frequency of 1 kilohertz, we're going to use a frequency of 5 kilohertz. As you can see, when the envelope function is a sinusoid at frequency 5 kilohertz, the output of our envelope detector does not fit the real envelope as well as it did when the frequency was 1 kilohertz. And you'll analyze why this is in the post-lab. Alright, so this concludes section 4.2 of the in-lab. As a quick note, make sure that you've been saving image plots for each of the 3 different cases, since you'll be turning those in for question 2 of the post-lab. And in the next video, I'm going to walk through section 4.3 of the in-lab, which is building and testing the output amplifier.